Hey guys, thanks for coming along. So yeah, that's the idea, right? Serverless strategies, I guess that's what you're here for. But it's all evolving, right? So we don't necessarily know where a lot of these are going to land. So what I'm also going to be talking about is some design patterns as well to kind of help you through. So my name is Brent Maxwell. As said before, I generally am an engineering lead. That's mostly what I do. But then bundled up, that sort of has rolled up over the years to other things like solutions architect. I've done CTO role a few times. And more recently, I tend to do CEO stuff. I've worked at some fancy pants companies with brand names, and I guess that lends some sort of credibility. But I consider most of my credibility from just being deeply involved with actually building real software that's used by people in the world. So I'm building my third startup at the moment. It's called SalesMuse. Igor's we work very tightly on a lot of the content that you've seen today is based on our learnings about building software together using these new tools. Now, about those new tools, they can be very useful. They can be helpful and good. For example, I created this awesome picture of a cyber llama with Leonardo.ai, one of our local Australian companies that's building in the space. And they have a fantastic product. But as soon as I went to try and roll my own stuff, I realized it's definitely not magic. AI is not magic. It is really, really unpredictable. And when my daughter sat on my lap while I was putting this presentation together, she said, Daddy, I want to see the pictures. I'm like, what do you want, Lara? What do you want? She said, I want a giraffe and a lion and a peacock jumping on a trampoline. And so running on my local machine on Stable Diffusion, I generated this masterpiece. And I kept trying and So this is the problem. It's unpredictable. So a lot of the themes around this talk are going to be on that problem. As developers, if you're trying to use this tool as part of the tool chain, how do you get control over it? And so it's important to keep in mind that, yes, everyone's talking about AI. Yes, we're in the middle of a cycle. And so for you guys that are actual builders, it's really important to keep in mind that it is just another tool in the tool belts. I remember when NoSQL started becoming more and more popular, and we went through that cycle, and a lot of my people, myself included, were like, NoSQL, some fad. Everyone's like, ooh, NoSQL. But the reality was that it was a really valuable tool that all of us that have been building with relational databases realize we actually have different use cases that fit different technologies. LLMs are another one of these. So a couple of key concepts. I'm sure a lot of you guys are probably aware of the different moving parts here. If you're in this talk, you're obviously interested. But just for anyone that isn't, I just want to run through a few quick things. First key concept is LLMs, large language models, and models. I'm going to use those terms interchangeably. And they really are just they're a system designed to understand and to generate human-like text. And we adapt that to do imagery and video as well. Training, tuning, and fine-tuning, these words, I'm all going to kind of lump them together. They are different, but they're similar in that they're basically taking, it's the processes through which you create a system, a model, by taking big amounts of data and processing that. And then tuning is how you sort of tweak and adjust that model. Fine-tuning is where you take additional data and then augment that model. But for our purposes today, architecturally, they're in the same bucket. Next one is retrieval augmented generation. This is really, really important for any of you guys that are building, because this is where you take external data source and then you mush it together with an LLM, and you try and make it do stuff that's more relevant to the specific use case that you're building for. And then inference, that's just hitting a model and basically asking it to predict, based on what you send it, what it should say next. And this is the text completion, essentially, that the LLMs produce. Text completion that seems a bit like magic, but text completion none the next. So it's just predictions based on that output. So in the talk, I'm going to be using that icon to depict where something is a good candidate for serverless specifically. And in this instance, for these concepts, RAG is a good one to use serverlessly, and inference is also really good to do serverlessly. So what that brings me to is AI and serverless. How do these kind of go together? And the best way to think about this, I think, is through use cases. What are we actually trying to do? Now, at the moment, I'm not too impressed, to be honest, because most of the use cases we're seeing are either chatbots, it's Q&A, which is essentially like an iteration on chatbots, usually using additional relevant data sources, and then image and video gen. That's the stuff that we're primarily seeing at the moment. But the good thing about that is that those are all event-driven. So they're particularly good use cases for us to do serverless stuff with. Now, this brings us to the other part of the equation, which is all that stuff I lumped into the same bucket before, which is training, tuning, fine-tuning. That stuff is generally going to require a cluster of varying sizes. But GPU clusters suck. And if you're here, then you're probably not a huge fan of running servers. I think servers need to get shot where possible and try and avoid using those, especially if we want to build stuff fast, prototype, we're building new features and products. Try and not do that unless it's really important for your use case. And I'll come around to explaining where some of the good decision points come in, where you might need to do that stuff. But yeah, they take a lot to run. They're expensive. Everyone knows about the demand of the H100 and A100s. And I think the most important part of this is that new generations are coming. So, this is the world's hottest space at the moment. Huge amounts of venture capital is being pumped into it. And NVIDIA is working on the next generation. And so the lifespan of a GPU cluster is probably limited because new generations are going to be faster and cheaper. So how long are you really going to want to run an existing generation cluster for? Question mark. The other aspect, I guess, to consider is the scalability, which is that the use cases that we talked about here, they often lend themselves to bursty workloads as well. And as you guys probably know, that's a great use case for serverless. Bursty workloads where you're not paying for the stuff when it's unused, you just pay for usage. And so, yeah, it works really nicely. So it scales quite well if you use serverless patterns. And the other part is it's easier to scale inference separately to tuning or fine tuning as well. So those are just completely separated patterns. Yeah. So this is one thing. When I was teaching myself a couple of years ago about the AI stack, I was trying to think when you're building a piece of software, you've got I was an AWS solutions architect. I'm pretty comfortable with SaaS applications architecture. What are the considerations if you're using an LLM? What's different? What do we need to actually know about? And the first one of those is infrastructure. That doesn't change. Same as a normal stack. The data is increasingly important now because data isn't just CRUD lookups in a database. You're also trying to think about what data has your model that you're using being trained on, and then is there additional data that's relevant to the use case you're building for that you need to assimilate into things. So that's another consideration. The model itself, and then there's three different levels of model you need to think about. One is the foundation model, which is ChatGPT 3.5 or 4 or 4.0 that was released last week. There's tuned versions of those models, particularly the open source ones. There's a whole big world of amazing work that people are doing on taking open source models and then tuning those for different use cases, making them cleverer, perform better, smaller, faster. And then there's fine tuning as well, which are things like LoRa's if you're doing the image gen. So RLHF, this is reinforcement learning with human feedback. You need to kind of be aware of this stuff depending on which level of those. If you're building foundation models, which I don't expect any of us are, that's central to the work. But when you're tuning or fine tuning, you still need to be aware of how humans have been included in the loop for getting this model to perform for a set of general purpose use cases. Trust and safety is another layer that you need to consider, which is, we will be talking about a little bit more. But that is basically how do you make sure that the model doesn't misbehave for the use cases for which it's intended. And then the application layer. Now, this is the one that I think we're probably most interested in today. So that brings me to the next part, which is the levels of control. Now, I haven't seen people writing about this stuff in the blogosphere, so hopefully this is useful to you guys, because this is something that has helped Igor and I make decisions about what paths we take and anticipate what paths we're going to need to take in the future. And the reason I'm terming it levels of control is when you get a foundation model, it's been designed to do a wide range of general purpose tasks, from reasoning to mathematics to code generation. But like when you have a use case that you're building for, you're trying to constrain it to do usually a small number of specific tasks, ideally. And if you're not, then you need to be careful, because your product could be very easily disrupted by the innovators in the foundation model space. So having control is, there are trade-offs that you really need to consider. It sounds good. As developers, we generally want control over our system, but that comes with huge costs. So I think of it in kind of like a funnel, which is the training is when you're actually training up a foundation model. Tuning that model is when you're tweaking the knobs and dials on that model. Fine-tuning is the when you take additional data and a model, usually that's been tuned, and you are trying to sort of retrain it to do a more specific job. And then you've got retrieval augmented generation, like I mentioned before, and prompts. And so as you go down, you have like kind of less and less control to the bottom. But the thing about that is that when you start building a product using an LLM, you're generally going to start out and you're just going to want to use a prompt to try and figure out how far I can go with prompt engineering to get it to do the thing that I want it to do. And that's a very, very, very good place to start. And so what we've realized as we've been building in the space is over time, you tend to move up the stack slowly, and that is a good approach because you don't want to jump into building LLMs and to try to do like fine-tuning or tuning. And so just at the application layer, I think that the largest majority of use cases can be done at the bottom two layers, RAG and prompts. The less control you have, the more serverless friendly as well. That's the sort of a key takeaway here, I think. RAG and prompts, happy days. You can definitely do both of those things serverlessly. As soon as you're moving into the tuning, fine-tuning, training, that's where you're working with GPUs. Any questions or thoughts about this at the moment? It's an interesting way of thinking about trade-off. I think it's interesting. It's been helpful for us as well. But you can go pretty far with prompts and RAG. So what are the tooling? What's the tooling that you need for this? So these are sort of the main three that I'd say most people are using in the space at the moment. LangChain is like an orchestration layer, and it's fantastic because it just cuts out a whole bunch of undifferentiated heavy lifting from doing stuff with prompts and with hitting different data stores, hitting different LLMs. They've just got a whole bunch of really good like plugins, essentially, to connect everything up. Llama Index is another tool that sort of specializes around RAG, and RAG is like, the more you start doing that stuff, the more complicated it kind of becomes. I think a lot of the use cases that we see are just like, adding a PDF and chatting with it and stuff. But the reality is that there's quite a lot of like art and science that needs to go into how you structure the data in a way to pull that in using RAG. And then Langsmith is one that we've started using more. Now, when we first started building in the space, we didn't kind of realize that there's the tool like this that makes it easier. But one thing you really quickly learn is that because prompting is so important, and you're trying to get as much control over the models as you can in that lower layer, you're going to just change it constantly. And so you need to version all of your prompts, your system and user prompts. And Langsmith's a tool by the LangChain crew that help you basically version it and manage your pipeline over time. So it's like having, it's almost like just like LLM pipeline orchestration. And so that's really important because as you change your prompts or as you change the underlying models that you're hitting, you need to be able to test those, and you need to make sure that you don't break shit along the way. And we are breaking stuff all the time, aren't we, Igor? It is really hard to keep these things doing what you want them to do reliably. So what are some of the other challenges like that, like breaking things? Well, initially you've got the models. Now, with the models, there are a whole bunch of different criteria when you're choosing something to hit. Now, my initial thinking was open source versus proprietary. I'm like, totally go open source, because then I've got control over the model, right? Like, it's open source. I can download it on my laptop, and then I know every time I'm going to hit it, it's like going to be the same. Totally do that. The problem with that is like, it's just very idealistic. The models are changing all the time. And so what happens is you'll be hitting on model, you've got your prompts working against it, happy days, and then a new update comes out or someone tunes one of the models, it performs better, it's cheaper, it's higher quality, and you're like, everything's changing all the time. So how do you stay on top of that? Well, that was the one that I use a tool to solve this for me, and it's by another little local startup from AI builders community called Artificial Analysis. These guys are fantastic at just helping you figure out like what the models are, and when a model is launched, they'll look at what's the latency, what's the throughput on that model, how high quality is it across a bunch of different scores. So it's really, really, really helpful, and that is and you are probably going to be finding yourself hitting a bunch of different models, so you need that. Then the next problem that we have is how do you get it to consistently output in JSON or in a consistent structure? Oh my God, this is so hard. It doesn't sound hard because when you look at the tin, there's this thing called tool calling or function calling. Those are used sort of semi-interchangeably, but those are basically ways of getting a model to output a consistent format that helps you consume a payload from an LLM and then do something with it, whatever your use case. But the problem is that they are a little bit inconsistent. There's slightly different structures and ways of interacting with those. But the good news is at least that stuff's kind of documented by third parties. So even if the model providers themselves are like, oh yeah, we totally do that, but they only do it with one model, not the other model that they're hosting, at least you've got like documentation out there that you can go and look up. So this is one problem that you can probably guess at here, which is, let's say you pick your favorite model, it's got the best performance, and you're not so worried about quality, you just want it to be really fast. That's great. Then you go and look at the feature set and you're like, it doesn't support structured output. And you're like, damn it. So you can't use that model. So these are some of the challenges that you've got. At the data layer, you've got prompt management, which I mentioned before. You need to be able to do versioning of that stuff, and that's going to change every day as you evolve your product and you're trying to keep it consistent. RAG is another thing. As I mentioned before, you need to be able to structure your data in a way, and you need to make decisions about the databases that you're using for that. So we're talking about another architecture soon that stores their vector indexes in Amazon S3, for example, but there's a whole bunch of different products that help you manage vector, and maybe you don't even want to store it in vector. Maybe you want to store them just as objects. So there's tooling here, luckily. Everyone's frantically trying to build the tools that we all want to use and love. LangChain, Landsmith, they help with prompt management. Llama Index specializes around RAG, and you've got specialized vector databases like Pinecone or Weaviate, but all the hyperclouds, they all offer vector options. We've been using PG Vector on render in our product at SalesMuse, and it's fine. It's been working, not a problem for us. But when you see the people debating it on LinkedIn, people are like, it's terrible, it doesn't do the things. And I'm sure, we know that we'll probably hit a point where it doesn't scale particularly well, and we might move to one of these ones. But again, we're just trying to build functioning software and serve customers. So we're sort of pushing the scaling decisions downstream a little bit. And then there's some quirks as well, and you need to architect for these quirks. So the first one is these LLMs are non-deterministic, and what that means, like I said, is that when you're building software, you generally want to be able to predict what it's going to do. They, by definition, don't do that, and so there's a whole bunch of things that you can do to try to get them to behave the way you want, but it's a really, really important thing to be aware of when you're using these things. And then the other thing is they're pretty easy to hack. I remember seeing this showcase of an amazing tool called Bland.ai, which is a voice agent that you can interact with. And they've got billboards up in San Francisco. I'm like, oh, that's so cool. So I sign up for the product, I'm interacting with it, and I give it a prompt. I'm like, you're trying to buy a car. That's all your job is. You're pretending to be a customer. You're calling me. I'm a salesperson. And I told it very specifically what I wanted to do. And so I got it to call me, and I'm having a chat, and the latency is amazing. The tech is super cool. But then I ask it, can you tell me about your fish collection? And it starts telling me about the fish collection. I'm like, God damn it. So you can hack these things. You can break them to make them do things outside of their intended use case. And so that is something you need to be careful of. Luckily, there's some patterns which I can share that help with that. So the seed or temperature, these are two different options. You won't have these on all of the LLM providers. OpenAI have set the benchmark for this stuff. So the seed is basically something that you inject alongside your prompt, and it is that seed is taken from a system identifier, which is generated every time an output is generated by the LLM. And that is basically a record of all the metadata about it, which is like the weights and the specific configuration of the model at that time. And so what that seed is it's trying to make it so that when you hit the model again and you pass in that seed, it gives you a consistent output or something close to consistent. It works to an extent, but they're non-deterministic. So it's a tool in the tool belt, and you might want to consider that, but it's not everything. And the other one is temperature, which is just like its level of creativity. So you can crank the creativity all the way down and also use a seed value, and this is increasing the chances that you're going to get some sort of reliability in your use case. So a couple of best practices just to think through. Loose coupling is really, really important, and this is because everything's changing all the time. And if you bind anything too tightly together, it's going to be really hard to extricate yourself out from that. So don't go into building in this space thinking, I have selected this model, and that's my model, and we're totally going to use it forever, because it just won't work that way. What you're usually going to want to do, if you're building any application with this tech, is you're going to be wanting to inject variables into new versions of your prompts all the time. And so you want to kind of make sure that you're managing your prompts separately and constructing and building those up before they get sent off and issued to the LLM. And the other one is tag, don't bind, which is just my way of saying you want to tag prompts, you want to flag them to be of a certain type and category, but you don't want to bind them to the specific models that you're calling, for example, because you might be able to reuse them. And so a lot of what we're doing is, we change the model for some reason or another because there's a newer, faster, better one. And then we're like, do we have to go rebuild all our prompts? No, we don't want to do that. So we use tagging to avoid that. Kind of similar is single responsibility. So this is the, hey, clicky, clicky. This is basically just ensuring that you've got different things that you're doing in your application. Don't try and get one prompt to do too much stuff. Try and constrain it down to do a very specific thing, and then just make a separate LLM call to do something that might be adjacent in your user experience. And then the other thing that I couldn't recommend more highly is leverage the third-party APIs. The idea of trying to host this yourself, I would shy away from. My friends at the hyperclouds probably want you using their tools, Amazon Bedrock being one, to run your own model. You can do that on Amazon, Google, and Microsoft, but there's just so many providers out there at the moment that you can use to host those inference calls that you're making. So try not to do that yourself if you can avoid it. So this is an architecture put together by AWS a while back, which I thought I just wanted to show, firstly because there's a talk on architecture, but secondly because it's just a really good basic view on how to architect in the space. So you can see here that the first thing that happens is the client will basically reach out. Let's say they want to upload a document that they want to chat with, or they want to ask questions of a PDF. That'll go into S3 bucket, and then a Lambda function will pull out that metadata, go and hit Bedrock to generate an embedding, and then it'll take that vector index and then dump that vector index back into the S3 bucket as well. Then a separate function, again, single responsibility, separate function comes in when a user comes and asks a question. It'll go do a lookup, try and find using keyword search or a similar sort of tech, the vector index that it thinks is most relevant to the search, and then go hit Bedrock to do the actual inference call itself. And then that feeds all the way back up to the user. So you can sort of see, I just thought this was a good example architecture of how there's a few different moving parts. They're all nicely separated out, and so they're very clear and isolated. You don't have single functions doing a bunch of orchestration and wrangling. A couple of design patterns, because we're running very low on time. These are three from one of my favorite VCs in the AI space, a guy called Thomas Tungus. He showed these a while back, and there's two of them, as you can see, that are relevant to serverless, but they're just important and good patterns. So I thought I'd share a bonus one for you. So the first one is the AI security design pattern. This is related to what I mentioned earlier about how it's really easy to break these LLMs. Now, one of my favorite experiences of this particular model is Perplexity. For anyone that hasn't used it, please give it a go. It is the best search engine in the world, in my opinion, at the moment. I use Brave and Perplexity, but it's more like an answer engine than a search engine, but it's got full linkability. And that's what they do. So if you write and say chicken sandwich, it'll rewrite your prompt using a proxy, and that proxy will be like, it'll take chicken sandwich, it'll be like, please tell me everything that you know about chicken sandwiches. Be short and concise. And then that'll feed that to the firewall. Firewall will go like, is this talking about, bad things or, chemical weapons or anything? No, cool, let this prompt through. And then that sanitized query is the thing that actually hits the model, and the responses serve back up to the user. So really, really good pattern. We're not doing this yet because we're early in our startup, but we're totally going to need to sanitize the prompts, because otherwise, as I said before, people will it'll start talking about fish or some ridiculous thing. Training, this is the one, it's not serverless, but it's just a really good pattern, which is just to make sure if you are doing any training stuff that you've got an adversarial model on the other side that is looking at the evaluations of your model and feeding that data back in to make sure that you're retuning the model to behave a certain way and to not behave a different way. And the other serverless one is the router design pattern. I think this is the one that probably best exemplifies what I've been trying to get across in this talk, which is different models have different characteristics. Sometimes you might want a really smart model, and it doesn't really matter how fast it is because it's trying to do some sort of reasoning task depending on your use case. For us, we're generally trying to get the models, we don't actually want them to be smart. We want them to be quite stupid and respond very simple things with very, very simple dialogue that's pretty constrained. So for us, it's like we're doing voice, like real-time voice stuff. So it just has to be incredibly low latency. Even if the throughput is slow, it doesn't matter. It's that time to first token we care about. So we can have a router that basically detects different types of queries, funnels it to the right LLM. This pattern's also good if you want to do fallbacks. So if you want to fall back from one LLM to another, you can take this pattern to detect what is a good criteria to move on. So best practices, use third-party stuff, plan to use different infrastructure providers and different models. Those are the most important things architecturally that I would recommend that you consider. And so, that really means that you have to ask yourself the question, do you need to run your own model? Do you actually have to, or can you do prompts and RAG? And how much control do you really need? As I said, you can do a huge amount of stuff with prompts and RAG without going up into the GPU cluster space. Anyway, I'm over time, really apologize for that. Thanks, guys.
Thanks, Brent.